Oh, hello. Fraction multiplication with Cuisenaire rods. What was that a fancy word for again? Fraction strips. Yes, fraction strips. So we're gonna learn how to multiply fractions using fraction strips or Cuisenaire rods. That's what we're doing, and so that's the representing and solving multiplication of whole number and fraction, and a fraction that refers to the same whole using objects and pictorial models, including area models. So objects, pictorial models, and area models. Things we might look at today: number lines, Cuisenaire rods, fraction strips. All right, so here's your warm up. With your table, find the pattern. What's happening here? Um, think about the products. All right, and on that last one, think about what 6 1/2 pieces would be equal to, and see if that helps you find the pattern. All right, and then we'll talk about it. Okay, welcome back. I missed y'all so much. Still miss y'all. I don't even know if how y'all are doing. I hope everyone is fine. All right, so let's hopefully these were easy because y'all know your math facts. 6 times 8 equals 48. 6 times 4 equals 24. 6 times 12 equals 12. 6 times 1 equals 6. And then 6 times 1/2 equals 3. All right. And the reason why 6 times 1/2 equals 3 is because let's say that we had 1/2, 2 halves, 3 halves, 4 halves, 5 halves, and 6 halves. That looks like 3 wholes to me, right? And there's 1 hole, 2 holes, and 3 holes. So 6 times 1/2. Remember, if you wanted to do that using the algorithm, 6 times 1/2. Remember, what we're going to do is we are going to turn the whole number into a fraction with the capital T pose. Remember, it's not really a capital T, it's just your fraction bar and a 1 as a denominator, but it looks like a capital T and it's easier to remember. And then after that, it's top times top. 6 times 1 equals 6. Bottom times bottom. 1 times 2 equals 2. And then before it's time to say goodbye, don't forget to simplify. You're looking at 6 over 2. Remember that 6 over 2 is the exact same thing as 6 divided by 2. And 6 divided by 2 is 3. So that's how we got our answer looking at the algorithm right there. So if you remember that from yesterday, good job. If you forgot, don't worry about it. We're going to keep on working on this. And then I think even tomorrow we'll probably take notes on it. All right. So moving forward. All right. So 1/2 times 2. All right. This one is kind of easier than the one that we just did, to be honest. So think about 1/2 times 2. Think about it as a picture, and then see if you can do the algorithm. Remember, you're going to have to turn that whole number into a fraction by putting a 1 as the denominator. Remember, anytime that there's a 1 as the denominator, that just means, you know, 2 divided by 1, for instance. 2 divided by 1 is 2. Anytime you have a numerator over a denominator of 1, it's just the whole number. That's 9 holes, 8 holes, 2 holes, right? If we add 100 over 1, that's 100 holes. And for some reason, this looks like the sorting hat. Gryffindor. Anyway, okay, so do this problem, and we'll come back and look at it. Think about pictures. Think about maybe even Cuisenaire rods or fraction strips. All right, see you in a second. Welcome back. So our problem is 1/2 times 2. Don't forget, it's easier to reposition these like sideways fractions as fractions with a numerator on top and a denominator on bottom. All right, so we have 1/2 times 2, and then we're going to turn 2 into our whole number by putting a 1 as the denominator. So this is 2 wholes. 2 divided by 1 is 2. And then we can just do top times top. 1 times 2 is 2. Bottom times bottom. 2 times 1 is 2. So we have 2 halves. And 2 halves is the same thing as 1 whole. So our answer is 1 whole. And by circling that answer, it almost looks like drawing 2 halves as 1 whole. 1/2 times 2, 2 groups of 1/2. So when we come back, we're going to take a look at this with some Cuisenaire rods and see how they got